Hi, my name is Josie, and I'm a supplemental instruction leader for Math 115, and today we're going to talk about testing hypotheses. So today we're going to test a hypothesis about a population mean where sigma is not known, sigma being the population standard deviation. So the problem we're going to use says, when 40 people used the Weight Watchers diet for 1 year, their mean weight loss was 3 pounds, and the standard deviation was 4.9 pounds. Use a 0.01 significance level to test the claim that the mean weight loss is greater than 0 pounds. And we know that sigma is unknown in this problem because it only gives us the standard deviation of our sample, which is 4.9 pounds. So there's 7 steps to testing a hypothesis. The first one is to write your null and alternative hypotheses. Our null is going to be denoted as H sub 0, and the alternative hypothesis is H sub 1. Now in this case we're talking about a population mean, so the symbol we're going to use is mu. And it asks us to test the claim that the mean weight loss is greater than 0 pounds. So that's going to be our alternative hypothesis. Mu is greater than 0. And your null is always going to be equals to, which is the opposite of your alternative. So mu is equal to 0. So that's our null and alternative hypotheses. Step 2 is to state our significance level. And that's denoted as alpha. And in this case, it said our significance level is 0.01. So alpha is 0.01. The third step is to identify our test statistic. And because we're talking about a population mean, where the standard, or the sigma, the population standard deviation, is unknown, our test statistic will be t sub n minus 1. And the formula for that test statistic is sample mean, which is x bar, minus mu, your population mean, over your sample standard deviation, over the square root of n, your sample size. The sample mean was 3 pounds. And then our population mean comes from our hypotheses up here, so it's 0. And then our sample standard deviation was 4.9, and n, our sample size, was 40 people. That's how many people we tested in our sample. And then the degrees of freedom is just equal to n minus 1. So 40 minus 1 is 39. And that'll be important when we find our p-value later on. And the fourth step is to find our test statistic. So in this case, it was t sub n minus 1. And we just plug in these numbers for the correct variables over here. So our sample mean was 3 minus the population mean, 0, over our standard deviation, which is 4.9, our sample standard deviation, over the square root of our n, which was 40. Now, when we calculate that with our calculator, we should get 3.872. And that is our test statistic for this problem. Our fifth step is to draw a picture of what this graph should look like. we're going to have a standard normal distribution, so we'll have a bell curve like this. And in the middle is our t, which is equal to 0. And then we're going to put our test statistic on here, which is going to be over here, because it's greater than 0. And that's t equals 3.872. And everything on this side of our test statistic will be the p-value. Because if we look back at our alternative hypothesis, it says that mu is greater than our test statistic, so it's going to be on the greater than side of the graph. Our next step, step 6, is to identify our p-value. So we're going to write p-value equals the probability that t is greater than 3.872. Now we can use a function in our calculator called TCDF to figure out what this equals. And you're going to put in your parentheses your left bound, which is 3.872, and your right bound, which goes all the way to infinity, which is denoted as E99. And then you also have to include your degrees of freedom, which we wrote over here, 39. And you should get, as your p-value, 0.0002. Alright, so for our last step, step 7, we're going to write our conclusion in plain English. So, since our p-value equals 0.0002, now we have to decide if that's greater than or less than our significance level. And our significance level was 0.01, so this is going to be less than our significance level. Now if your p-value is greater than your significance level, you fail to reject your null hypothesis. But if it's less than, like we have here, then we will reject the null hypothesis. So since our p-value is less than our significance level, we reject the null. And because we rejected our null hypothesis up here, we can support the alternative. So there is sufficient evidence to support the claim that, and then we just plug in where our original claim was, that the mean weight loss is greater than 0 pounds. So that's our conclusion, and that's how you do a hypothesis test about a population mean where your sigma, your standard deviation, is unknown.